So compared to a proton, a grain of sand is really big. Colliding two particles as small as protons is more difficult than colliding two bullets shot from the Earth and the Moon. So in order to create all those collisions at the LHC, they have to use, well, a lot of protons.
The beam is made up of 2,808 bunches, contains 100 billion particles, each of those.
Those bunches are lined up every 25 billionths of a second. That makes 280 trillion particles traveling around the LHC at once. So that's a big number.
The awesome numbers at the LHC are largely possible due to the invention of a much more humble particle collider, ADA.
So this is ADA, which means anello di accumulazione.
The ring for accumulation.
So this is really the first machine of this type.
ADA is more than 4,000 times smaller than the LHC.
ADA was conceived in 1960 and was realized in less than 1 year.
ADA never discovered new particles, but this great leap in physics and technology showed that magnets could move particles in a circle for a long period of time, allowing for the possibility of collisions.
It's really the tiny father of all colliders, including the LHC.
Here at CERN, the home of the LHC itself, world-class physicists from around the globe are collaborating on a revolutionary experiment. Of course, it's not the first time in history that's happened. In 1941, physicist J. Robert Oppenheimer and some of the world's smartest scientists began an experiment called the Manhattan Project.
Now all the scientists had to not talk about what they do, which is normally not the way how science works.
4 years behind closed doors later, they had created and tested the atomic bomb.
Shortly after that, CERN was created, redeeming the name of science.
12 countries created here in Geneva the CERN laboratory.
CERN is not the Manhattan Project.
Lots of people come and say, I don't suppose we can take pictures, and the answer is yes, take as many pictures as you like. There is nothing secret here.
And the LHC is not a bomb.
It's not going to blow people up.
CERN is a laboratory that exists to do fundamental research. We are expressly forbidden to do anything else.
After 30 years of open-door science, CERN took a huge step. In 1983, they began excavating the tunnel for a gigantic particle accelerator. That same tunnel would become home to what is now the LHC, the collider they could only imagine 25 years before. And now, the LHC will begin colliding particles at energies never before reached. By a machine, that is.
By replicating the instant after the Big Bang, there are many that believe we will somehow see proof of another astonishing possibility. Extra dimensions of the universe, beyond the three we can see.
Real physical extra dimensions of space.
Explain that one, David.
What is extra dimensions? Oh my God. There's this, and there's this. 3D, you know, things are in 3D.
You think of X, Y, and Z, so 3 dimensions of space, and then time.
An extra dimension would be another direction that's, you know, at a right angle to those three. But you can't imagine that. Though it's nearly impossible to visualize extra dimensions, just remember that a microbe inside a piece of paper could never visualize a universe beyond that 2D piece of paper.
By definition, it has to be very small because we don't observe it in day-to-day life. In other words, we don't live in that 5th, 6th, or 7th dimension.
How do you look at something small? How do you see something small?
Sometimes you have to look big to see something very small.
So stack a few universes together, or really overlap them, and what you have is extra dimensions. The bigger question is how and where would we find signs of extra dimensions?
The two protons collide, and now they have so much energy compared to collisions we have been studying before that they go over threshold, and they go indeed in a regime where these extra dimensions can be visualized.
Albert works directly across the ring from Atlas. His detector experiment is called CMS. Its name stands for compact muon solenoid. But don't let the name fool you, it's not compact at all.
It's a 15-meter high experiment, and it's about 24 meters long, so it's not small. Welcome to CMS.
The heart of CMS is the single largest and most powerful superconducting magnet ever built. If all the energy was released from the magnet at once, it would be enough to melt 20 tons of gold instantly.
This experiment which you see here is actually a modular experiment. It comes in 15 different modules, and they were actually constructed on surface before they were lowered down in the hole here.
The largest of these modules weighs well over 2,000 tons and is filled with more iron than the Eiffel Tower.
Like Fabiola and Atlas, Albert and CMS will be looking hard to the detectors for signs of dark matter and other discoveries, including extra dimensions.
And we have a number of special signatures which we know of, special events which we're going to look at or going to search for.
For example, if two quarks collide and produce a gluon and a graviton, a particle that escapes from the detector, we may have hit the jackpot.
So what we will see then is an enormous large jet going in one direction, and there is nothing to compensate that jet, so there will be sort of a large missing part in that event.
So what might look like this typical example of a particle collision at CERN would be missing an expected spray of particles, or jets, meaning that the particles may have literally escaped into extra dimensions.
Extra dimensions are just cool.
I wouldn't think of it as a different kind of life form would live in there, because I think we're talking about something very small, 10 to the minus 15, 10 to the minus 20 meters, kind of small, not something that, you know, that you would bounce a ball in or something like that.
But what would all this mean to me?
What would it mean to you if we found extra dimensions? How would I know? I don't know what it means. I don't even know what it would mean to me.
It's much more than just an intellectual theory, because if we find it, it really does exist.
And the fact that that's not science fiction, that that's a part of the physical world is astounding.
All of the experiments at the LHC, CMS, Atlas, ALICE, and LHCb will be looking for a myriad of theories, like extra dimensions, by using completely different technologies.
That gives you confidence in your result.
One thing they have in common is the enormous amount of data they have to deal with.
We will have about 10,000 CPUs to analyze LHC data here at CERN. There will be a number of very large computer centers around the world,
which are all going to be connected on what is called a computing grid.
And with this computing grid, it will be like having a single computer with more than 100,000 processors.
It boggles my mind.
So what does the rest of the world get out of all this?
Aside from the myriad of scientific breakthroughs that have occurred at CERN over the years, there have also been quite a few unexpected benefits that have been born there as well.
The World Wide Web was invented at CERN, as you know.
In the first stages of creating this computing grid, the IT department at CERN developed a method for using the existing internet structure to post information to physicists around the world. CERN had what they needed, so they gave away the infrastructure, calling it the World Wide Web.
Yeah, fine. The web came from the LHC.
And you use it every single day, as well as other physics-generated toys.
And quantum mechanics, of course, is why you get these cell phones and radio and all these bourgeois comforts we wouldn't live without anymore.
I'll have to take it, excuse me.
It's science who develops the ideas, and sometimes we can even manage to make it useful for others.
The fact that the World Wide Web is something that is a spin-off of what they're actually trying to do gives you a sense of the intensity that people have in attempting to answer these questions.
And that same intensity may have led us to the verge of finding the God particle.